Okay. Bailed out. Do the thing. And then, fail to send an email. Actually, you know what? My phone did a ding. Is that probably you, Cameron?
Yes.
Said, okay, fine. Which means I need to go also, never mind. Let me go check Twitter in case somebody's trying to knock on the door and can't get in. The usual story. No, okay, so it's all calm at the moment. Fine. So Coffee Compiler Club. This is my usual start of meeting spiel. You're being recorded. If you don't like, bail out now. Theory says I'll get it out on Twitter within the week because last week I had real life intervene, and so I'm backed up. Anything to do with compilers, language runtimes, garbage collection, typing systems, concurrency, language implementations, code gen, syntax, whatever you want. I don't have a set agenda, reserved the right to moderate, never had to do it. That's it. And we're good. Oh, there's 1,000 notifications right now. A bunch of people ask me questions on Twitter. More people showing up here. I'm getting behind her. There he goes.
Dad always used to complain that the hurrier he go, the behinder he get.
Yeah, it's true. It's true. There's a racing term too. Going fast is slow. Like if the turn is complicated and subtle, then going fast is slow and going slow is fast. Because you go too fast in the first part of the turn, you get too hot, you get your car unsettled, and you get sideways and squirrely on the second and third parts, and you can't come out of the turn with any speed. And so if you go in slower on the first part of the turn, you can hold it through the middle, and you come out with solid acceleration and good speed. And so it's fast is slow and slow is fast. Same kind of deal. If I do too much and do it too fast, then I end up making mistakes and go slower. So there you go.
There were a sign on the old cars that they do not have airbags, and the sign says, "We do not have airbags. We die like a real man."
I didn't ever see those signs, but okay.
Yeah. I will send it to you.
Okay.
If I see
I was a kid. My parents had a car. We were in the back seat of a Volvo. You could walk around. I know my little brother was on the shelf in the back window, the rear deck shelf in a bassinet. We had my sister and me in the back seat, and my baby brother in a bassinet on the rear shelf. Mom and dad in the front two seats. What you gonna do, right? That was, that was 60s. That was the era.
It's the stopping suddenly.
Yeah.
That's correct. Yeah, going fast never hurt anybody. It's the stopping suddenly. Fine.
Yep.
Also, Cameron, are you doing okay? I notice you're not in Cliff's house.
I kicked him out.
He did not pay rent.
So on this computer, I don't have my Cliff background.
Gotcha.
Because somehow Zoom hides it somewhere.
Oh, excellent! I'm safe.
I haven't taken the time to decompile Zoom.
Yeah, next time you're out in California, you can come by my house and get a real picture of you in my house.
Sounds like fun.
Yeah, solve this problem once and for all, sort of. So, okay, so fine. I'm going to ignore the Twitter feed stuff because no one's asking me to get in. And there is okay, let me do it again. There is a Google Docs link, which I will attempt one more time because all the latecomers won't find it in chat. So this is the New World Order, or attempting the New World Order again to use a docs for chat. I'll do my little status bit. I've picked up another guy beating on AA, for theory purposes, Marco Cervetto. He's been doing the type system for Pony for like a decade. And he's having fun, like wailing away. And so I have these really abusive type system test cases now. And, so far I've been keeping up with him, and all the bugs have been sort of minor implementation from too much cut and paste and running too fast earlier without knowing what the hell's going on. So it seems to have settled down until, you know, the next abusive test case appears. He's basically writing, I want to say, piano math, bools and successor and ints and all the integers in types system. Funny looking stuff for typing, but I seem to be doing the right things at the right times. So maybe it's going to hang together here. And then I'm back to like backporting this back to the main AA base. So that's it. Been fun stuff though.
So
That's all still in HM9.
That's also what?
That's still in the HM9 file.
Oh, HM9 was the last peel off. The most recent's in HM, which when I peel it off will become HM10. So it's always HM is what I'm hacking on for the typing games, and HM 1 through 9 were prior iterations that stopped at some reasonable point. Here for shits and giggles, I'll throw out version to see. Oh, I don't have the really abusive ones. These are all too simple because I cut it down. Here's a reasonable guy. Google Docs will hate me here. Let me find an empty spot in Google Docs. So threw into Google Docs, test case with Java 8 syntax. So ignore all the extra strings, but void is equal to an empty struct. True has a struct has an and, an or, and a not, and a then else. And false has an and, or, not, and a then else. There's some way to blend them and peel out trues and falses. He's got test cases that are roughly double that size that I've passed through, seem to be doing okay with. But I'll go in for all your types on that. And all the functions are all types of, you know, unused to each other recursively left and right. So it's been, like I said, it's been a fun round of hacking on getting the type inferencing doing what you expect.
Because types are hard.
Yeah, there's annoyingly more complicated than you'd think. And of course, I went hog wild on hacking Hindly-Milner because, you know, I could. And then I had to go back and find all the places where I didn't get it right. But I think, you know, like
your assignment, you're reassigning true and false.
Well, I don't have an assignment for true and false. So true and false aren't names or anything in the language. They're just, it's like Python or R. True is not Python, R. It's a true is just a user variable. So he's assigned it to be a struct, which has the following fields, which are all functions. So he's made it basically a class object, an anonymous class object that has an and, an or, and a not, and a then else. And he's made a false, which has got the same thing except, you know, inversions in various places, followed by, you know, the bigger test cases start using it and abusing them to confirm it behaves like Boolean algebras. And then he's got a version with successor and, you know, 0 and a successor to go do little bits of math. But
usually the types in a structural type system, the types become large when you start combining them. We have to start to look for these.
that was the last round of bugs. Was the type I get out of this is actually reasonable here now. So that obviously belongs in the chat then. So the type I get out is false is a named type a colon, which we'll see a lot of, which is a struct. You know, false is a struct that contains an and, not, and an or, and a then else, which has a lot of A to B and B to A. And true has a, you know, is a named D, which has an and, not, and an or, and a then else. And they mostly reflect on each other, but they don't talk back and forth because they're not actually bound together unless you do something sensible with bool sub as a common type between them, and he doesn't at the moment, or in this test case. So that's the type I get out of them, and it's basically 1 for 1, same size type as the underlying structure. So yeah, it looks like the right thing to me.
Well, you got to pick some building block.
Exactly. Right. And like I said, I'm backporting it to the main AA, and I think, you know, I think it'll give me Like AAs without the Hindly-Milner is giving me decent types down the line up until I hit like the things you use in functional programming. So I'm curious to see how my examples show up in the functional programming side, but I'm highly hopeful now that it'll pan out.
Yeah. So I wanted to say, so the approach I'm doing is model checking. And I was kind of curious, like how powerful it was. And I found this paper, a type system equivalent to a model checker. And so it turns out the simplest model checking program, you have flow typing, you have union types, and you have intersection types. And so you get all those for free when you do model checking.
Right. Yeah, I know you can get a pretty powerful system out. Yeah. Throw your link.
I mean, if you have intersection, union, inverse, and recursion, I think you now have Turing completeness.
Right. So like, I mean, that's the benefit of model checking, is it's this uniform abstraction, and you get all these things that are really hard to do in type theory, and they all look Turing machine. So
yeah,
yeah.
Aaron, throw a link out. You had a.
It's in the doc, I believe.
Oh, it's in the doc. No, oh, okay. Yeah, I don't not been doing the docs in the YouTube videos. There you go. Let's see if it'll let me open this here. UPen. Yes. Yes, yes. Yeah. This is the other way around, of course. So yeah. Type systems and model checking are two prevalent approaches to program verification. Okay, and they're going to go through what it takes. Fine. Yeah, I hope I don't go there. It's not that I don't want to go there. I want to know that my algorithm for computing the answer is fast and reasonably efficient and gets, canonical answer. The key thing for a usable language is compiles fast enough and people can understand in theory what the typing does.
It has to compile fast, at least to me.
Says the guy who's suffering with Scala compile speeds. Yep.
Well.
Yeah.
And I believe that combination is a pretty powerful, and it's right on the sweet spot of the type systems. Because after reading.
It's my healthcare.
Cool.
Well, I'm a healthcare guy. Hello.
Yeah, because after reading 40 plus something papers on type systems, and I finally begin to understand what they're talking about. It's pretty easy to just lost in type theory.
I will say the Pony paper did change my perspective on type systems to be like, oh, the type of this thing tells me what other references exist in the universe. That was interesting.
I did not read them. Maybe share a link.
Hold on, let me find it.
Yeah, I mean, most of the idea behind a type system is just being able to prove whether or not, when you say A equals B, that it's legal.
It will find that this is a very hard thing to prove. It has at least 3 interpretations by now, and they are growing. Why is A? What is? The main argument is what is a type? When you start to compare them, then what is equality, and then it's exponentially more hard.
I didn't mean equality in this case. I meant assignment. But yeah, same difference. Or pass into a function, or right. So you have R values, you have L values, and what's allowed to be, what's a legal construct.
Yeah.
And how many of the illegal constructs can you predict at compile time? That's the other side of it, because there are a lot of languages that prefer some or all of that checking to runtime.
Yeah. Yes. The main argument revolves around what is exactly a type. Does it has a structure? Does it has a properties? And from there, you try to prove something about the types in order to extract what a type is and how to use it. Yeah.
Guys arguing what a type is?
Yeah.
We're not arguing yet.
Yeah.
I'm sorry, what? You're not?
We're not arguing yet.
Oh, okay.
Yet.
Yeah, you're really faint, Cameron. I think it's your distance from your mic. Yeah. Headphones is fine. Yeah, I have no idea what a type is these days. I've been
Okay,
doing sets of values for a long time,
Yeah.
even as I do the dual thing, which is not a set of values.
I wrote a
Would it be
blog
possible to
post.
send out a Google Doc to the e-list? Because I'm on my portal right now and I can't actually read the thing.
I'm sorry, you
On
want
a
it
device that I can.
the Google Doc link was sent to chat. You can't read the chat?
Well, I can't open the thing you sent to the chat.
It's on a different device. He has to type
Yeah.
in the 56-bit number in the URL.
Where do you want it?
Exactly. By email would be totally cool, or Twitter DM, or whatever's easiest.
Okay.
Appreciate it.
Yeah, what's your email?
You can do max@bernsteinbear.com, and hopefully this will be scrubbed from the.
Yeah, I'll have to go type it out. So max at
I gotta say, I like the domain name.
Thanks.
Bernstein Bear.
Yeah.
I don't claim I'm going to get it right here.
It's my last name on Zoom plus the animal.com.
Yeah, now I'm reading your thing here. Probably, okay, fine. So Google claims sent, so you can tell me if you get it.
Sweet, thanks.
Yeah. I got a delivery failed. Max at Baronix, I'm missing an N. Let's try again.
It's not spelled like the Bears, the famous Bears.
Cliff, I'll send it.
Okay.
This video is going to require more editing to bleep out the AI.
Like I was looking for URL shortener in the meantime, but it seems like they either don't work or they've all been shut down. Like
I used to run a URL shortener.
You can honestly blame IRC for a lot of those being shut down. Or
why?
Some way to get
Thanks,
for,
Kevin.
for people like me in high school.
This is why we can't have nice things.
Yeah. I feel like that about build systems too, or especially Gradle.
I think what's going to be cool is if Google ever builds something so you could read stuff on the internet with it, like I don't know, some sort of reader where you could queue up stuff to read. And that would never go away. It would be so popular.
Yeah, fine.
Nobody here old enough to remember Reader? Come on.
Adobe Reader? No. What are you talking about?
No, Google Reader.
Google Reader was their RSS feed
consuming
application.
Fortunately, I never fell
I'm
into
so
that
bitter.
hole. Okay, fine. There were a bunch of those, like Google Groups or Google whatever. We're going to be Facebook. And I'm like.
Well, but they measure the success of things on how it allows them to spy on you as a potential advertisee.
Right, I get it.
Which
And
Google?
Reader apparently didn't help enough because it was only being used by nerds, and they're like, nerds don't buy enough stuff. So.
Nerds don't have any money. Some of them do. It's true.
Drop the McCarthy 91 function in the chat because it's got some recursion in it, and you can totally do constant propagation through it, but it's sort of slowly moving constant propagation. So the type that you get out might depend on sort of how aggressive you are willing to be in the constant propagation.
Oh, this function in the not in chat, but in
the doc.
In the doc. So which version? There's a couple flavors floating around. Static val m91 is n is a function of n greater than 100, subtract 10. Otherwise, add 11 and self call. Is that what I read it?
Yeah, so it keeps calling itself approaching 91, essentially one at a time. So in theory, it could take a lot of iterations of this thing to get to the fact that it's going to eventually be 91.
Right. So the usual story for me is that I run the land of, standard constant propagation says you widened, you're good to an int, you're done. So 1 pass, 2 passes, you're an int, you're done. HotSpot runs a range thing, which allows you to widen a few times, and then it goes to the largest range it sees, which, since you wrote it as a recursive function, is just going to blow out to an int. If it's written as a loop, I'd spot the n greater 100 and probably cap you up from 1 to 100. But that's it. It's going to be one or 2 passes and you're done.
So how do you decide which ranges are legal in your system? Are you just looking at the constants and being like, hey, I see a range here? Or do you just decide, yeah, you get int 8, 16, 32. You have to fall into one of the nice
so
buckets.
you're talking about Java C2, or are you talking about constant propagation normal, or are you talking about AA?
Constant propagation in general seems like you might get into this place of your types depend on the implementation of your constant propagation.
It depends on the implementation of your lattice. So the lattice forces you, so constant propagation always approximates, right? Exactly your McCarthy test is you have to approximate somewhere. So what is the level of approximation you do, right? A common approximation, especially for functional folks, is to go to int immediately without having any constants, right? And the C guys would all love an approximation that says int 8, 16, 32, 64, and so on. And that's kind of what you get out of the Java typing as well. But you can have other more refined versions that approximate in different ways. Like I said, I did ranges and hotspots strictly to handle small entry case statements and enums. So it's a different level of approximation. And then that turns into the level of precision you get out of your constant propagation algorithm.
So at least when I was playing at the AA REPL, sometimes it gave me back 91 and sometimes it gave me back int, depending on which number I put in initially.
Okay, so in AA, the standard thing at some point, depends on what level, what version of where you're at, because I've been doing a lot of bug fixing on in the type struct branch today. But if you were running the REPL, that was an older one. Should have been standard constant propagation. Okay, if you got different numbers out of that one, then that should have given you that's an error. That could be filed as a bug. Because that one should have been straight up constant propagation, and constant propagation should just give you one or the other answer. Should be highly normalizing, you get a fixed answer. There were a few earlier versions where I chose to unroll or not, kind of semi-randomly, which would give you more precision in a few cases, but not like your McCarthy example there. I claim that guy coulda, woulda, oughta, shoulda bottom out really quickly as an int and be done. I don't know why how would you ever get a 91 out of a constant propagator there? You actually got a 91 out of that?
Yeah, if I put in something like...
It depends what you pass as a argument.
Yeah, you pass a first argument in.
Yeah, I call it in one place and I give it an integer.
Yeah,
not a generic integer.
Calf itself plus 11, that way would grow. If it's greater than 100, then subtract 10 and reiterate.
No. But the constant propagator is going to come along here. So you have a bare function. He's going to assume it's called by anybody who does anything useful. He's going to clone it out. So he says an n is an int. So you can call it with n with anything you like. So the initial value of n is whatever int you pass it. So
yeah, what makes it tricky is that it's the M91 of M91.
Yeah,
so you get an unpredictable amount of recursion. It looks like it's a constant 2 there, but it's not, because that second one.
Okay, I'm not even getting there. I'm saying you start out by having a function, because it's a upwardly exposed public function, M91 is an open variable. The REPL is going to assume it's called by everybody on the planet yet whose code has not yet be seen. Somebody calls it with 1,000,000. So therefore, n is any integer value.
Constant propagation will not be able to extract because it doesn't know what you will pass in. If you pass in value, then it can try to propagate it.
Right. If M91 was hidden and then called only in the hidden place with a number, and you return that result, then you get the constant propagation of whatever value you passed in M91. So if you basically pass it in a 1 or a 0 or something, he'll then constant propagate along and come up with do something. But I don't unroll recursion very far. Definitely small functions with few primitives, I do unroll, including this kind of thing probably lands in the unroll category.
Yeah.
And he'll like unroll a little bit and say it's a self-recursive function. I'm not going to unroll very much because that's loop unrolling, and I just no into it, bottom it out.
So it basically
get you to 91.
If this is known, that this is basically boils down if a constant propagation.
If it's not known, it's any integer. So I don't understand how you ever got anything like 91 out of it. I'm confused.
if you pass it, if it will grow plus 11, it will pass itself, and then it will pass itself, but it will add 11 to the argument,
I mean, the
and
math
eventually
all,
will grow beyond. It will grow beyond 100.
right. The math all does the right answer. I mean, in terms of the inline gives the right answer, the constant folding gives the right answer. It'll grow and shrink and whatever. The value for n obviously goes up and down and waffles around. I claim constant propagation should very quickly say int and walk away.
Yeah, this is basically the answer it can give because it doesn't know what.
I heard
can
Aaron
constant.
say I got a 91 out.
Yeah, if I was within 2 or 3 inlinings, it seemed to just be like, oh yeah, that's 91.
Oh, if you passed
But
it,
if it was like 4 or more away from the number, it would be like, that's an int.
So when you get a 91 out, you're saying you passed it a number.
Yes.
Oh, yeah. If you pass it a number, like if he's unrolled it a few times, he does a top level unrolling. He'll do a top level unrolling. He'll peel the first iteration or two. So if the answer falls out in the first iteration, you'll get the first iteration. You know, the M91 called with 99.
But that means in your language, as you change the config option of how many layers am I willing to unroll, I've changed the types in my system.
Yeah. So I've already
feels weird to me.
It is, and it's not what I want. And so it's already, I've known for a long time that I have to deal there. One of the issues was I was unrolling for things that I wanted to rescue that the Hindly-Milner will rescue for me.
I'll take a different opinion from the both of you, which is you're not changing the types, you're refining the types. So it's simply, it's a cost trade-off.
Yeah.
And, you know, being able to give you an actual value back is a much better type than one of 4 billion values, right? So it's not that it changes the type, it's that sometimes it might be better at discerning the type.
You get a more refined type, but the flaw here is that I then rely on the more refined type for the following code, which as soon as I lose the inlining, which is giving me the more refined type, for whatever reason I lost inlining, I suddenly lose my typing, right? So now the question is, when is inlining, which amounts to type refinement by there's a word for it, the CFA 0 and shit like that. There's like, you're expanding the underlying representation in order to get more precise types. This is a well understood in a bunch of theoretical places. But to use it in a language, I think I have to have a rule that says it will always inline in the following context and never in the following context, and everyone understands the rule. And I don't know if I have a rule that's simple enough. So right now, my theory is I'm going to inline anything that is textually written as a standard primitive in the language, because those are all functions that turn into the primitives after inlining so that you can overload, you know, with the various operators. But if you do a plus of ints or a minus of ints, you get the int version instead of the float version. That'll inline and that'll give you a slightly more refined type, but one where you already know what the hell's going on anyhow, so it doesn't change it. Whereas sort of generically, I have M91, I'm going to peel it a few, and I'm going to inline it a few. Like there's two ways you inline here. One is you peel a top level iteration, and then you call it one down. And the other one is, of course, you inline the ones on the interior, and you have a body that has more executions of M91 before it loops.
It basically here it doesn't. It's still unknown that will be beneficial to constant propagate it or to unfold it. It has to chain it.
There are a lot of reasons in Java code to peel one iteration every time.
Yeah.
Because you get a lot of tests that are invariant in the loop, but they only execute in the loop. You peel it, they all happen before the loop. This will be all your null checks and your original get an array reference and array bounds, array length, and shit like that all happen in the first iteration.
You can eliminate a lot of them
here.
Yeah, you can eliminate a lot of them just at one iteration. Yeah.
Yeah.
The null checks. Yes.
You always peel one in Java.
So do you think it's an acceptable rule to start with some hard-coded number? I peel twice.
It's no acceptable rule. We're making this up as we go. Is it acceptable in practice? Well, there's no practice on AA except you and me, right? So is it, you know, does it make sense to peel an iteration? Well, this is where you go from a language theoretical point to a feel. right? And does it feel wrong? If it feels wrong, maybe it is wrong and we shouldn't do it. Right now, like I said, I'm breaking overloads. I'm inlining to remove overloaded functions as a thing I think is probably okay to do all the time. Loop, self-recursive functions and peel and iteration, I don't know that makes sense. Things that are purely getters and setters, if I inline them and I get a strictly stronger type, maybe that's worth it. But a classic getter setter with Hindly-Milner, maybe I get that answer without inlining in the typing system. And so I don't care. So this is an open question.
At least to me, it better have a flag in the compiler in order to tell it how effort to invest it, to unroll, to unwind, to constant propagate.
Right. Right now, I did it because I could, because I was curious, because I was trying to fix the overloads. Okay. So having the overloads fixed reasonably, and then Hindly-Milner coming down the line, that decision of inline needs to be revisited. And maybe the answer is it only does it for primitives. It only does it for certain size function bodies that are well understood by everybody involved, including getters and setters. And maybe, if we get more complicated, you rapidly get more and more open questions about what it means. But people who have a validation test followed by returning a value, right, kind of makes sense if it inlining would strictly sharpen the type over what you'd get out of Hindly-Milner or what you get out of Hindly-Milner plus GCP. So it was a type strengthening operation that I probably don't need and leads to confusion. I may back it off.
Yeah, but we have to be more careful in order to not to introduce too many flags to, like in HotSpot, for example, there are thousands of flags, and this is a sea of flags because you basically have to be a T800 universal machine.
No. Those flags came around because it was a new thing that no one knew what the right answer was for all these decisions being made. So you left them on a flag so you could diddle with them later. Then later it comes that 90% of the flags have a decent setting that no one should bother with. 10% have a setting that experts want to screw with, and 1% of the flags are people actually care about on a sort of regular basis.
But
when you started, you didn't know.
I will argue that the flags, they not only refine the behavior of the hotspot, but they change it in order to fit your use case, and from there becomes.
GC definitely has ergonomics flags that totally change its behavior that people care about left and right. They get giant GC pauses or not. They can run all day in production or not, according to GC flags.
But basically, there are so many flags that they have companies that have a machine learning to learn what the flags of the JVM are.
Talk to these guys.
Yeah.
I just say that the root problem here is go.
Okay.
Set the main question the right way as the default, and you don't need.
Yeah, the main question is if you have a hammer, okay, then everything, it has to be a nail. That's old spiel talk, okay. But if you make it that much configurable, it becomes unusable because there are so much configurations, there are so much things that you can change, and it's better.
It is certainly not my goal to expose all these flags to like some end user of AA. Instead, it's my goal to explore the realm of language implementations and typing things to see if I can, get a sweet spot, but then lock it down and say, this is what it is.
A much more reasonable approach is there somehow to the flags to infect each other in order to propagate to a chain of changes that will configure the compiler in order to try to manually change each flags to your will. There are a set of configurations that go together, and if you switch one flag on, then it propagates in the rest of the compiler chain.
I'm not designing a flag hierarchy right now, so I have no flags controlling modalities in AA. No intention.
At the last talks, when we spoke for the flags in order to compile fast and this was something like that, but it's baked into the language.
There's keyword support intended, not implemented. Yes, for which the keyword support would simply change the shape of allowed programs disallow things that are syntactic sugars that have unexpectedly high costs. That's not what I would call flag. I'm sorry, I'm saying that command line flags is what I'm hearing say flags. So this is like a lexical typing.
Yeah, we will have to distinguish what the flags. Do the flags just refine the behavior of the compiler or completely change it?
No, because typing flags. I'm talking about not flags, keywords to change the type, which would disallow programs.
Okay.
Specifically saying allocation is expensive. If I allocate in this hot loop, I made an error.
Okay. Yes.
As opposed to a slowdown by tenfold that I didn't discover until later in life. Right?
Yeah,
Or
this is sensible.
Please, Mr. Compiler, tell me where I allocated by mistake, because I didn't mean to. And the compiler will pop it out and say, and here you did a new allocation hidden under your auto boxing, which you forgot to disable or whatever. Hell, fine. But this is not command line flags like HotSpot. We're talking about typing in the language, like changing the language Java with some sort of flag that says, but see, Java changes the language only on a major version number change, right? Like my example here needs to have multi-line strings. Well, they should have Java 11, but not an 8. Okay, but that's nothing to do with any command line flags and not what I would call flag.
Sorry, I'm jumping in a little bit after not paying attention to the first part, but are you discussing a specific case or a general case of types to inform like performance or performance changes as types?
I am talking about the general, well, Theodore is talking about something, he and I are going back and forth. Okay, fine. I am intending to put in this class of types that are intended to support performant programming, where the typing is designed to allow or disallow syntactic sugars that have unexpectedly high costs. You accidentally wrote some code that you didn't understand at the time you wrote it, did something that was more expensive than you were hoping. So the canonical easy case is that you're doing an allocation per something X, where X is a very large amount, and suddenly you have a lot of allocations. The allocations typically will die young. The direct GC costs are very low. You run out of memory bandwidth because allocation burns memory bandwidth like no tomorrow, and that's where your time goes. And canonically, I have all kinds of test cases, but they revolve around eating giant log files, where the first thing you do is you do a buffered reader.readline, and you got a string out under the hood without realizing it. And 1 byte became two bytes in and 2 bytes out and 4 bytes. And if I then split the string and I got to 8 and plus headers, I got to 10 to 12 bytes for every byte I read. And suddenly I'm 10 to 1 slowdown. And it's just bandwidth on allocation that was stupid. They didn't even do the allocation. Slightly different paradigm for how I read the terabyte log file, has no allocation whatsoever, gives me the same answer 10 times faster.
It'd be cool to say like, so I worked on a runtime that had UTF-8, and so there's a very common operation of like index into the string that you want to say, well, don't fucking do that in a loop because you'll die.
Yeah, exactly.
So like mark this thing as linear, and if you're doing it in a loop, you're doing something wrong.
So like Julia has the default UTF-8 strings, and I was talking to the company that were trying to do TCP/H queries, which involved doing a Boyer-Moore algorithm looking for particular string patterns in billions of strings. And as soon as you went to UTF-8, like you sucked, like it was horrific. So getting away from UTF-8 in Julia was really hard. It's quite difficult because it was everywhere. You had to have nothing that looked like a string. So strings had to not be strings anymore, anywhere, everywhere. And there were, of course, everywhere strings. So you had to screw with them to get them into fucking byte arrays. Then you could run a Boyer-Moore algorithm at the speed that you expected, and life was good. I don't want to fall down to that rat hole. So if you want a UTF-8 string, you can get one. If you index into it, you do. And if you say, please, Mr. Compiler, tell me if I'm indexing to doing one of these performance hacks, it'll say, you're indexing into a UTF-8 string. Fine.
So how do you annotate that? What's the...
However, I annotate a function with an extra type that's not part of the arguments of the return type. So right now I have a typing syntax, which says for a function, I would put a colon and a function syntax. There's a room in there for adding a keyword somewhere, and haven't decided where it goes, but it'll be a keyword that says something like no UTF-8 or :fast for a default rollup of a bunch of things that probably changes over time. But like no allocation, no UTF-8, no, I don't know, no virtual calls. There's a variety.
You're marking the user, not the like the caller, not the callee.
The type is assigned by whoever is defining the function and has a lexical scope, so it can go deep. So it's in your code.
But we will have
I'm saying
to.
if you want to mark the callee so that you know, just like this function's expensive.
You could imagine annotating the function, or you could imagine annotating the call site.
Yeah. And I was currently, in theory, annotating a function, but I guess I could annotate the call site too. That's not actually that hard. What it really means is the call site takes a function argument, which gets annotated on the spot, which I can otherwise do anyhow. But
the
for
compiler,
syntactic sugar reasons, you probably want the annotation on the call site.
Yeah. The compiler have to support the case to show you the code chain, where the arguments, it has to support that infrastructure.
You get a compiler error. How do you get a typing error out now?
Yes.
Well, right now, whenever I have a localized typing error, I grab a bunch of stuff in the current context and hang on to it. And if the error gets reported later, you get something out.
But this will get stitched as a function call graph, and it has to show you this function in this function.
Yeah, your error is going to smell like a stack trace. At this location, you did an allocation. Here's my thing that called thing. Here's the spot where you put that.
No, it only in theory it only goes one layer deep. So same error happens if I decide that I have like a function that only takes a mutable and it's handed an immutable, or vice versa, right? Somewhere deep in the guts, somebody tries to assign to a thing that's immutable. The blowout has to happen. Where do you report? Right. So the report can happen somewhere along the food chain between where it came from, where it went. In flow typing land, it's easy to find these report points. And HM, it could be, you get a funny thing where I got past some function I computed over here to some call site over there, which deep down inside, it took that function and applied it in a zone where it said fast and didn't. That's the same Hindly-Milner error you're going to get when Hindly-Milner says, otherwise I have type constraints and I'm going to have reporting problems, same as Hindly-Milner does.
As long as you're not doing the same OCaml thing where it's like, didn't match, good luck.
Yeah, exactly. So I put a lot of work on the flow typing side of things to get a decent error message out. I have been looking at Hindly-Milner types, and they get ugly. And that's an open question. How do you report? Elm does a good job. There's a bunch of heuristics. The strategy I'm taking, which is I talked with Chris Latimer at Swift. They have a similar strategy. You have a bunch of heuristics in the beginning to cover all the 99% cases where a user does this common stupid thing for your bug reporting. And then you have to have some other reporting after that. That's the fallback. And it just says, it didn't match, but maybe I can hand you more context.
There's this guy, Esteban Kuber, I've been following on Twitter, who, I'm realizing saying his name in a recorded session is weird, but he does a lot of work with Rust error messages, and like whenever people report a hard message that's like throws people off the deep end, he spends a lot of work going in and investigating, and it's really cool. Like
throw out the links in the docs.
Yeah, that's his Twitter, and then I'll work on finding
find a doc to the paper. He maybe doesn't want people accessing his Twitter, but maybe he does. I don't know. But the work he's doing, if there's a link, it'd be nice. Having said that, I don't
look into how Rust manages to get good error messages in their macros.
Right. And then do the borrow checker, and you get a fail in the borrow checker. What's the error message look like? I have actually no idea.
But they are still confusing. They may be precise, but they are still confusing if you do not know exactly what is happening.
Yeah, they're a bit of a hit and miss, as in there's only so much you can do in a message that sort of fits in one line, and that has to be understandable. My issue is more that they try to illustrate or show the source code where the error happens, and in case of a borrow, if you say you mutably borrow something and then later on you do it again, the error message will include like the part saying, hey, this is where you borrowed it the second time, and here's where you borrowed it the first time. And so you get these little code snippets. The issue is
And-
that if you try to quickly scan over that, it can be quite tricky to figure out which one is which. Because it's basically the sort of noise of like arrows pointing to lines. So you're like, okay, wait, where's my actual error?
Right.
And so it's this sort of delicate balance of, do I provide too much info or too little?
Yeah, right.
Because finding that spot in between is really difficult.
Yeah, Elm did a
And
lot of
they-
work on error reporting, has done a lot of work on error reporting.
And they embed the RFCs in the error message. I don't know why this is maybe useful, because you can pretty much lost in the error message. For more info, see RFC blah blah blah. In the rest, I
There's a
don't.
command line flag you can use to display them. So in theory, you can do all of this in your terminal. Like
Why
you
it's
don't
not
need to
switch off?
Google.
If I ask it, then okay. So
Yeah,
just for
so
the-
I don't know the flag. I think it's like, rust c -- explain or something that you copy paste the error code. And then usually you get actually pretty decent examples that in quite detailed explain what the actual error is. I think it's a fairly sensible way, because otherwise you end up dumping these basically entire books in the output and nobody's going to read those. I think, at least with the borrow
If you-
checking, for me, the
if your
recruiting issue isn't...
message,
Sorry, go ahead.
go ahead. Go ahead.
No, I was going to say, like, for me, the thing with the borrow checker, usually it isn't so much finding out where it happens. Like, that's usually fairly clear. It's more case of finding out why. This is better nowadays, but I think up until like a year ago or something, at that time they made some changes to make the borrow checker smarter. But before then, there were fairly common patterns that were totally valid, but the borrow checker's like, no, I don't understand this. So, here's a big error. And so it's often more sort of trying to figure out, okay, why is it not allowing me to do this very simple thing? Prime example there is if you have, say, an instance method, and you have a field that you want to pass immutably to an instant method that takes a mutable reference to self, it won't allow it. Because it will say, we can't call the mutable method because you've already immutably borrowed this field. And this makes for cases where if you have a structure where you have to say, in my case, I had sort of a hash map-like data structure. Mapping, in this particular case, string escape sequences. So you have the input character and whatever to replace it with. So I had one for single quoted strings, double quoted strings, etc. And I had them in a field on a struct. And so I would pass them to a method that would sort of consume its input and try to, in this case, tokenize a string, taking this map as a way of replacing it. And this tokenizing thing was a generic function. Didn't really care about the type of quotes, that sort of thing. Rust wouldn't allow that, because it's just, no, you can't call this mutable function while you're also immutably passing this this hash map, essentially. And so I would say there it's usually more the changes you have to make to satisfy the borrow checker versus the error messages. Those are usually fairly okay.
Yeah, staring at your Twitter example, but I don't do Rust, so it looked pretty obtuse.
Mostly it's meant to illustrate that someone has spent a lot of time. Whenever someone reports like, oh, what the fuck does this mean on Twitter? He's like, well, let me, and then goes in and spends the work to go like, well, this thing, and they come together to mean this, and that actually doesn't probably mean what you meant here, and blah, 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 blah.
Right. Yeah.
I also don't know anything about Rust.
That's all good. So the thing that got me on Elm was the automatic currying if you didn't pass all the arguments. Space for function calls and then the arguments spaced afterwards. And if you were short an argument, you just had a series of things that were spaced apart. Maybe there were complicated expressions already. And what you got back out was perfectly valid. It was just a function that missed the last argument that you didn't have, but you missed one in the middle. So you had a function instead of a result. And then you promptly pass that along, and sometime later you try to pull it out and do something resulty with it. And it said, you need a function here. You're missing an argument here. And you're like, I'm not missing an argument at the call site. No, because it's not a call site. It's just, it's a thing. It's a result. And that was the mystery was, oh, some other place far, far removed. I simply failed to pass an argument.
That's definitely a challenge too with languages that are typeless or loosely typed.
Oh yeah, well, I'm strongly typed. It allows automatic currying.
That would be a nightmare.
So the one that always bit me, I think we finally fixed it on the error side, but let's say you had a method called, I don't know, is empty, to use a Java example, right? So collection is empty. And someone types in code because they haven't looked at in a while at the API, and they're like, we've got some collection C, and they say C dot is empty, but they don't put the parentheses on, right? So because of that, they're pointing at a method like C dot is empty is actually it's a function because I've provided a target, which is C. So I've bound the target to the method. It gives me back a function.
Yep.
And I try to assign a function to a Boolean, and you can imagine the error message you get is like, it's not saying you're accidentally forgetting to call a method. It says, I can't assign this to a Boolean.
Right. I can't assign a function to a Boolean.
All objects are not
a function. There's no what? Yeah. Yes, that falls in my camp of here's an easy heuristic to check for first when the fail happens, and report it this way as opposed to that way.
But there is nothing more complicated in a compiler than providing good error messages. Everything else like type systems, Hindly-Milner, assignability, capture, whatever, those things are super duper easy. Like, try to build a good looking error message and you'll switch careers.
Well, there inherently isn't good formalism for how to report things that don't match the formalism.
Yeah, exactly. Right. Well, yeah, one of the games I'm playing is that I've declared all manner of errors to be part of the formalism. So if it's purely a syntax error, you get a parser level syntax error. But if it's a typing error, those are part of the formalism. So I can carry them around and hand them back and forth. And then maybe when they're reported, I have more context and more sensibility about how they're reported. We shall see if it pans out in practice. But yeah, the whole notion of it's not in the formalism. So how the hell what you're doing is you're making it part of the formalism, but in an ad hoc, painful way.
Yeah, the feature I really wonder about is the adjacency for function application with a single argument.
Yeah.
I could totally imagine being an awesome feature that enables all kinds of powerful DSLs.
Yeah.
And I can imagine that being a wart that leads to lots of bugs that drive people crazy for decades.
Right, nightmare, yeah. And so I'm doing it, and I'm trying very hard to make it hard to make a mistake there. But I could go another layer in and demand that this not be the default behavior unless you ask for it because you're a functional guy. What I'm doing now is everyone takes the one argument, and if you pass it a tuple, then I syntactic sugar explode the tuple as your arguments, your normal C-style arguments. But it means that I can pass.
So there's nothing actually special about function name, open paren, close paren.
Yeah, it's nothing special.
That's the function takes whatever the next thing is, and if that's a tuple, great.
Yeah.
And if you want named arguments, pass in a struct instead.
And then I'm building a DSL for loops and while loops that way, because you pass in a function immediately afterwards instead of an argument list over a while, and the while keyword is actually normal user variable. It just has a function that takes a function and it executes it until it hits true or false or whatever the while does. But that's a DSL building operation exactly being done by having function application be done that way. Now, will it lead me to funny errors where I forgot to do parens or whatever? Maybe, and then that's going to turn into right. So Cameron's is empty case. You forget to open close parens on after an is empty. The next thing in line becomes the argument to is empty, right? And then
But you also better be good at making sure that those tuple creations and then unpackings don't.
Yeah, those are hard guaranteed by the typing system that they'll unpack that. But if you want to pass in a constructed tuple that came from elsewhere, he'll do the right behaviors, but he won't guarantee to unpack. So if you do a Varargs thing where you build a complicated tuple with a bunch of arguments and you pass it to a printf, you might get a tuple constructed and unpacked. But if they're adjacent to each other, I hard guarantee you, it's like scheme demanding, tail recursion. I hard guarantee you that one gets unrolled, and that one gets unrolled in the typer. Typing system does. That's a kind of an inlining variant. He just eats that.
So your Varargs powers in this language are just your tuple unpacking syntax.
Yeah, pretty much. That's my current theory.
And if I want to do tuple unpacking anywhere, I have all the same power I do for Varargs.
Yeah, that's the theory. We can argue that it doesn't make sense or it doesn't work, but that's the theory.
It's a good theory. No, it's a good theory. I mean, that's what parameters are, in a sense.
There's a lot of
Python has been moving in that direction. That it used to be there was a bunch of like namey things you could do in function arguments that you couldn't do inside tuples or lists, and now they've gotten better at like, this is my list, which is made up of these two things, and then the expansion of this list.
Which is the length encoded one, Cliff? Is it CDEC or Pascal?
the length encoded what?
Wasn't there one of the two common calling conventions, stack calling conventions? Didn't it push the number of arguments or something?
Well, Java has a statically encoded.
I'm talking assembly.
Oh,
CDECL versus Pascal.
Not CDECL, because the count.
CDECL was just backwards, right? CDECL was just push the parameters on backwards or something.
You're talking about Varargs then.
I can't remember.
For CDECL. None of the C guys ever pushed a count of arguments on the stack unless there were Varargs.
Okay.
I would vote for the Varargs. I think
right, but
like
Pascal might have pushed an argument count on the stack all the time. I don't know. Pascal was P codes. Bet you not.
Well, you're talking, so Pascal, Turbo Pascal was P codes. Yeah, that was
the original Pascal was P codes.
Was it really?
P codes,
Was it a stack machine or a register machine? Or
stack machine. And then
I know Anders, it was Anders that wrote Turbo Pascal, right?
Oh gosh, I don't know who wrote it.
Turbo Pascal.
I certainly used Turbo Pascal. It was the most amazing thing. Some of the modern IDEs could take a look at Turbo Pascal and revisit. There's some mistakes they make that Turbo got right.
It was better than BASIC.
It was better than a lot of things.
Anders wrote it in the early 80s, Turbo Pascal, and that was it was available on the Zilog Z80.
It was available on PCs at some point because I used it a bunch.
Right. Well, the Z80 was the poor man's 8086, right?
Yeah, right. Okay, fine.
So for those of us that couldn't afford an Intel.
Well, I had the Radio Shack Trash 80, right? That was one of my early
there you go.
Assembly hackers, totally. You're right. PCs were expensive for a while. Yeah, that's right. I forgot.
I got a used Apple II Plus for $2,000.
Yeah, there you go. Computer history. Here we are. Okay, fine. So what about stacking with putting your arg counts? Well, it's Varargs. You got to have an arg count somewhere. Java automatically arrays you, and then you get the length in the array. And the automatic array thing plays havoc with hash consing because you got an automatic allocation of something that you wanted to actually intern in the hash table of internal
I saw something recently with a language. I don't know if it was Java or C# or a different language where they were talking about adding support for multiple Varargs in a single method call.
I'd claim that's not necessary. You're just done. Just go allocate a fucking array and pass your piles of unrelated things in. The syntactic support is such a narrow use case there. Like, no, stop while you're behind before you get behind her.
I mean, I still want my Varargs for printf.
You want your Varargs for one.
Varargs should go, at least only for printf.
But Varargs.
Well, I don't know. It does. No. It works okay in Erlang just to have an array or a list or whatever it's called. It's fine. It's like 2 extra characters. You can live.
I do Varargs things all the time, but only with one list of things. As soon as I have two associated lists, it's time to rethink what I'm doing.
Varargs also pretty much required if you use basically functions for creating arrays and list kind of types. Because if you in my case, Scala does it too, where there's no actual array literal. It's like a function that you call. And you need Varargs for that, or you need to special case this function. Say, oh, only this function can use variable arguments that will special case it. But then you basically have ad hoc for
list 1, list 2, list 3.
Yeah, shoot no.
I'm fine with list and dictionary being macros that look like functions in certain languages if you want that.
Now I'm doing Varargs. And my array creator is a function that takes the Varargs. Same kind of syntax deal that Scala does.
So what do you do if you're proxying Varargs between, so you've got one function A that takes Varargs and then you call it, and then it calls a function B that it passes the Varargs to. Does it allocate a new array? Does it just pass down the same one? Because Python, you get into this hole where they can't be the same. They have to be different objects.
Oh, no.
So, because otherwise Python wouldn't be slow, and that would break the contract with the developers.
The calling convention where you first call the Varargs converts it from a variable length list to, for me, a tuple or an array. Now you have an array or a tuple, and you're going to pass that to the next guy, not a variable length list. So the guy who receives it as a Varargs, not an unpacked pile, but as a Varargs, he gets the summary item. That's the tuple. Now he's got a tuple.
The thing that it's calling takes Varargs. Like, so do you re-explode it, or do you just...
The guy who says he takes Varargs lies. He takes an array. The call site packs the Varargs into an array.
Okay.
Not the receiver. So it's a call site syntax. It's not a receiver syntax or a function syntax.
Why not just have both like Python,
Well, because you don't know how to pack and unpack or whatever. Yeah. Then there's a compiler optimization that says I'm going to pack or pass them in registers or however the compiler wants to cheat under the hood for you, but you don't need to. The typing wise, the function says I take a Varargs. What he really means is I take allow the call sites to pack and hand me a packed list, and I'm receiving my list as a single thing, which is a packed list. That's your example off of the.
So why do you care? Like at that point, why have the sugar?
If you don't declare the sugar, then you'll catch syntax errors where somebody passes the wrong argument count. Otherwise, everyone by default says, and extra arguments that I've never heard of and I don't really care about, I'll pack on the end as the Varargs thing. If I don't put a Varargs on the F, if the ..my list doesn't have the ... then what do you do with extra arguments? I'd love to have a complaint from the compiler saying you screwed up, right? And instead, it's going to be silently the last argument in my list is actually an exploded array of all the extra arguments, and I get a fucking tuple of God knows what the call site accidentally sent.
We got rid of Varargs.
Yeah, I want the user to buy in on Varargs. Yeah, I want them to admit, and here be Varargs, right? There's a lot of these cases like currying, like my Elm experience of currying says, I want to have currying available in the language, but not by default. You have to ask for currying. Either at the call site or the function, one of the two has to say, and I'll admit to a curried version.
That checks out. And then currying also can be surprisingly expensive if you don't mean it.
No, currying is just another function wrapped where some of the arguments are known and some are not. You just get a different function. You can go write the curried version from the uncurried function like in half a line. It's like
no, I mean as far as intermediate closures, if you don't do it right.
Oh no, then you're suffering. No, then you're buying closure issues. No, as soon as you escape things into closures, you pay a price, and that's one of the fast slow flags that I have in my head to go deal with. If it's a purely a stack allocated standard closure thing, that's your free one. If it's a upwards compatible, didn't escape though, but I require looking backwards, maybe there's something to be done. I don't know. But if it's I escaped it and I have to heap allocate your closure, that's expensive. So something has to happen there.
You know, currying tends to force that in most languages.
Why?
Currying,
Like
because-
OCaml just ends up getting
because-
passed around and heap allocated, and it's a whole thing.
Why does?
Because it creates a new function that's stateful in that it has one of the parameters bound as a result.
Yeah, but if
of
you were to
creating that
call
function.
the whole function with all those arguments in the first place, you have just as much state. I don't understand why.
No, you have none. You just use the stack for that. You can't use the stack to do currying.
You're saying if I upwardly expose the curried function, pass it along somewhere else.
So I have a function that takes two parameters, A and B.
Yeah.
I say f of A, I get a new function that takes B. But
Yeah.
that function is different from every other f of A where I provide a different name. So there's no one place in memory that I can put that curried thing. So I can't keep it, well, I do, but I can't. There's an optimization I've designed for this, but in general, you can't keep it in program space.
Well, you have to keep this version of A somewhere, and the function that talks.
Right.
Yeah.
Right. You need a unique
Right, but
function
isn't that
pointer.
just any other escape analysis? That A is the A on the stack unless it escapes, in which
Well,
case.
no, but you can't use the stack for the function because then it triggers the NX bit because you can't jump to your stack. It's
You're saying
a safety feature.
the implementation of the function. So for me, the functions are all fat pointers that take a display, have a closure pointer. They're fat.
If you have fat pointers, that may allow you to work around this altogether. Yeah.
That's interesting. Okay, fine.
Right, the thing I want to
How does the fat pointers help?
an identifier for which function it is and the state that it's going to eventually be called with.
Right.
So the fat pointer allows you to bifurcate the function pointer itself into a static pointer and a data pointer. So it's basically combining CS and DS in a single pointer.
Yeah.
CSIPD. Yeah.
So the function space is actually small. The count of unique functions in the planet is small in your
Right.
program. So thousands, but not millions, probably hundreds, actually, not necessarily tens of thousands even. So some pile of bits will uniquely identify a function. And then you need something else to just refer to the display. I'm calling display the closure, which however you get your data pointer from. And if it escapes,
stack allocate your
and
closures?
that's the fail for the standard.
So what was that, Max?
malloc.
Do you stack allocate your closures if they don't escape?
That's the intent. There's no implementation. The intent is to be, they don't escape, they're going to be stack allocated. If they do escape, that's a flag you can ask to be told about. So the typer knows they're escaping or not, or they have the shape of an escaping thing or not. And then if the optimizer can heap allocate it because it's smart enough, then it is. But the typer will have a set rule that says you have an upwards exposed variable that you're capturing and passing along, this will by default heap allocate, and you said no heap allocation of closures, so therefore
The difference between when you wrote HotSpot and when you wrote this is in 2007, AMD introduced the NX bit. So if you stack allocate your closure, it'll actually fault. It'll panic. Your program will be ripped.
Yeah, you get shot down.
Right, but only the data of the closure, not the function of the closure.
If you try to put the code on the stack with the closure, that's the trick. So the common implementation strategy at one point would be a trampoline, where
trampoline, you jump onto your stack.
You jump onto your stack, yeah. Where the data is, you jump to the okay. So that got ejected. Now you have to have a different way to get there. Some strategies would be I heap allocated the function, which all it did was loaded the pointer and jumped to the shared thing, the common function, but I had to heap allocate the function pointer. Or I do a fat pointer where I have a reference to the code and a reference to the data, but the two go together somehow. And in my current typer, I manage them as a fat pointer with two separate parts that I understand each independently, and I type analysis and I flow analysis and blah, 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 all right shit.
And then what you can do is you can call the function passing the other half of the pointer, and then the function can unpack its arguments as necessary.
And I have
in theory.
I have in the typing, the unpack operation baked in, and functions all take a hidden extra closure argument. That's their up stack closure that they deal with. And that's all part of the typing system, really. Oh, okay. So bye. It's good to seeing you.
Okay, let's shift gears. Cameron, how about concurrency thing you explain it? You can give an overview about the services that can call each other without the taking a lock.
Oh yeah, give me a second to remember what I was talking about.
Okay,
was,
the service
yeah.
that when they, okay.
Yes, right. So, right, I've been working on a problem where, for sake of argument, just imagine when I say service that I mean thread for the time being.
Oh, I'm sorry, what?
Imagine I mean thread when I say service, so some transition from thread to thread. So if service A equals B equals C equals D, it's as if I'm going from one thread to another, to another, to another, which is ridiculously expensive. So instead, what we do is when one service calls another, it has some state transition, but basically it's just creating a fiber, which is generally a very low cost operation, and then it has to take ownership for that service that it's running in. And so there's a bunch of volatile comparison swaps, whatever, that have to be happening to make sure that only one fiber is running at a time inside a service. So I've been working on getting rid of this because the use case that I have in mind is, so all IO, for example, is done on services. So if I have Cliff's financial services H2O system reading lots of data out of a stream and parsing it as fast as possible, it's going, somewhere under the covers, it's going read byte, and it's doing that 1 trillion times because it's got a terabyte of data that it's going through as fast as it can, right? So if I'm going from one service to another every time I call read byte, that means I have a minimum in what I just described of 2 trillion volatile, 2 trillion memory barriers that I got to trip over, or at least 1 trillion volatile reads and 1 trillion cache flushes. So there's some heavy cost to it. So instead,
do you ever inline across service boundaries, or that's not a thing?
I'm about to explain how we could. So instead, when a service creates another service, it creates it initially in a state. This is the design. None of this is implemented yet, but creates it in an initial state that's owned by the service that creates it. So if the service that creates it then calls it, it's a zero cost operation. So no one else can use this created service until the creating service agrees to give up exclusive ownership to it. So it's kind of a biased locking approach, if you will. Mark, did I explain this to you the other day? Did we talk about this?
Yeah, I'm still not sure I'm on board. The code Cam was talking about replacing is my code. And I would argue that when contention isn't there, the cost is not that high. So I actually have some performance numbers on that. So you're looking at saving 12 nanoseconds.
Times 1 trillion. Okay.
So, I did the bias locking hacks, and then I did the compiler elision of bias locks, where you legit knew that there was no chance for it, and it wasn't that big. So IO maybe wins.
Yeah,
Okay,
I think
so
ultimately it's the contention that you need to avoid, but by the time contention's present, the optimization you want to put in place doesn't work either. So I would argue the hardware cache is already managing this well enough. So it's basically the argument, what's the cost of a write to a plain field versus a write to a volatile field? And I have the 4 versus 16 nanoseconds on my laptop.
There you go.
But if I don't have any memory barriers, all of the costs of writing to a field are made as if they're asynchronous from the profiling point of view, right?
You may have to go to the next layer, which says that after the inlining and removing the barrier, I get the further effects of inlining, which is to say I have the contents of this service injected as code into my, and now I get other optimizations pay off more.
Right. So there are some other optimizations that we're trying to figure out if you fit into this. So for example, when we pass data from one service to another, it has to be immutable, right? So if I have some mutable state and I'm passing it across a service boundary, that state has to get a frozen copy of that has to be made to pass to the other service. So, this type of optimization in theory could eliminate that requirement, because basically what it does is it defers all of this until the safe point. So it hits a safe point, does a volatile read, says, does anyone have anything I need to pay attention to? Because otherwise I'm just going to go straight on and process as fast as I can, right?
Yeah.
So it gets to the safe point, it sees that someone has written something into that flag, right? And it says, oh, I have work to do. I have to figure out. And it looks and it sees, oh, someone wants to call my service. So I have to now untangle.
Mm-hmm.
Because up to this point, I can treat multiple services as if they're in one zone. They're all kind of tangled together. So now I have to untangle it. So basically I have to rewrite, at that point, I'd have to rewrite the, potentially even rewrite the heaps, right? If I tried to organize it in a single heap, I'd have to disentangle them, for example. And anything that I copied across by reference, I'd have to now make an immutable copy of and things like that.
So you mentioned that the service is akin to a thread. It has its own space. So it has to somehow, the code from the service B have to enter the code in the service A in order to stitch them, in order to.
More like a deopt.
Right, it's basically a deopt.
An escape. For my stack allocation, you did an escape to the heap, and you have to do a minor GC cycle and walk and then discover all the things that are connected and tease them apart.
And what's cool is that each service basically does its own GC, because it doesn't outside of this one exception that I just gave you, which is I'm cheating by not keeping them separate. Outside of this, each service is its own domain of data, and it never has pointers outside of that, except to shared immutable spaces that are cooperatively copy compacted.
So in this aspect, they're just like actors. They're just like actors in this regard. There it has its own spaces.
That's kind of what it's designed based on, yeah. I mean, that's the same concepts.
So newborn services are always like exec. They're never like fork.
Say again?
Newborn services are always like exec. They're never like fork.
That's a good way to think about it, yeah. But, from a developer's perspective, it's the same as saying like new string or new runnable or new whatever. Like, it's just a new object. It just happens to be a service object. So we anticipate that, a typical running server would have millions of services running, where you probably wouldn't want millions of threads.
I give you my standard generic advice here, which is do no optimization before it's time. Get somebody who's got a painful problem that this solves before you try to solve it. It's good to think through, this is how it could be solved. It's not necessary to.
Where's the fun in that?
Because you get to be driven by user experience. Somebody comes along and says, hey, I'm running HotSpot. I'm doing this following crazy thing and it sucks. And I thought it would go better. And what happened? And you take a look under the hood and you think, oh yeah, okay, fine. This optimization will fix you. Oh, that felt better for me, but it also meant that I did more targeted things.
Well, how HotSpot ended up with many flags.
Some of that, it's kind of unrelated. The flags were things you didn't know about. The user was complaining about something in their face. You knew you didn't need a flag. It was going to be done.
So to your point, though, we often don't implement the optimizations initially, but we go through the process of proving that they're possible, because otherwise, if you can't see the optimization, that probably means you're not ready to implement the design at all.
Right. You have no way to, you'll box yourself in a hole where you can't. Yeah.
Exactly.
Yeah. I did a lot of
believe
those
that
because no one knew any of this stuff, or even what was necessary or coulda, shoulda, woulda. So there was a lot of those that just required big rewrites to make it happen. But those big rewrites usually open up a whole lot of other fun.
But the cool thing is that it also kind of plays into the whole hotspot concept. Like until someone tells me they'd like to do some work on my behalf by stealing some of my work, by running some of that asynchronously or whatever, until then, I'm just kind of running straight flat out, right? And if there are several other threads that kind of need access to the same thing, then we can detect the contention for it. And so you kind of have a difference. You have a difference between straight through processing, kind of single threaded model where there's no memory barriers, you're just running as fast as you can, versus kind of cooperative, cooperative multi-threading, and where there are multiple things that could be run asynchronous. They don't have to be, but you could chew up more cores and get stuff done faster, versus contended situations, which are those are the trickiest.
You're providing the user a lot more opportunities to run in parallel and to think about the problem as independent parts that you will choose yourself, whether they ran in parallel, the runtime chooses whether they ran in parallel actually, or they just single threaded and more efficient or whatever. But the user can structure their code in a way that's conceptually all these parts are parallel.
Yeah, this is a value. You reason them about separately, but you run them as a one program. You run them as a one coherent program without the cost, which is the value, which is cool.
Do you have any concept of affinity or anti-affinity of services in the language? Or if I want to be like, hey, there's these two things, but I really want them to intensely communicate with each other, please put them on the same core. Or I have these two things and I would really like them to be in separate failure domains, please put them on separate racks.
Right, so, well, keep in mind, none of this that I'm describing is distributed across multiple processes, so they'd be on the same server.
So everything's in one shared memory domain.
Right, but it's obviously the same design is intended to be used to build distributed systems. So, kind of, as I enjoy doing from time to time. But the goal of it is that, generally speaking, the developer doesn't tell you that stuff. The goal is that our design is supposed to be able to detect it by keeping statistics of how it's running. So, it detects contention, it knows its size of its backlog, and so on. So it's like at some point, the service would actually shift from being just an asynchronous thing to actually probably being its own thread with its own non-blocking queue. So it's like, if it gets busy enough that, there are certain things you can't easily do more work than just one thread doing one core just doing that one thing. And that's what we look at as, that's our kind of theoretical maximum, is a situation.
Yeah, in my experience, affinity is usually learnable. Anti-affinity is usually not learnable. You can't look at the system and go, oh, for reliability reasons, these two things better be on different racks.
Well, we certainly did that with data.
Once Cameron got this model with these functions, with these services A and B, the B service becomes A service begin to cause B service a lot, and the A service would say, "Come on, guy, hop in my truck. We'll drive together, and we'll be more efficient." That is all you need in order to. It's like runtime stitch the functions if the service is a function from the outside, and you made them composable in this way.
Yeah, except that we start with them in the same truck and then we eventually kick them out.
Yeah. Cool.
There's a story I like, which I don't actually know whether it's true, but I retell it anyway. There was someone who stole a bunch of credit cards and rented AWS servers to do a DOS attack. And the person they were attacking was also on AWS. And the system realized there was a lot of bandwidth between the two VMs. So it put them on the same boxes as each other so that the DOS attack was running at the full speed of the North Bridge.
Well, they tried to be helpful.
Yeah, exactly.
Computers were a mistake. Computers were a mistake.
Teaching Sand to think was a mistake.
Why? Computers are the most brilliant things that happen to hundreds of years from now.
Rocks weren't meant to
Until
think.
now. Mm.
There are days where I think that when I'm fighting with CMake, but
CMake was a mistake.
CMake still exists?
unfortunately, yes. Gradle also unfortunately exists. Actually,
Oh God, I so hate Gradle.
oh God,
We CMake is trying to
They do
complete,
exactly
right?
what you tell them. The
Yeah.
worst thing about computers, they do exactly what you tell them.
Yeah, the problem with Gradle is on the surface level, it seems perfectly fine. But when you try to actually write a plugin, when you need to do something that's somewhat complex and you need to just generate a dependency on the fly for whatever reason, the entire system is filled with tiny paper cuts that eventually just make you bleed out. It's just, and we just got so mad at it. It's like, well, we don't want to deal with Maven because it's Maven. So we're like, because we don't want to write a plugin. It's like, well, Ant exists. And we just went back to Ant. We just went back to Ant, and while it's just a crap load of XML, it's a crap load of XML that we can actually understand. So
At work, we use Pants, which is the port of Ant to Python.
Yeah.
How do you do the fixed fonts? Or how do you coding style in Google Docs? Where's the coding style button?
There isn't. It looks like someone copy and pasted and it cloned the formatting. But this is why whenever Google makes you do an interview with them and they make you code in a Google Doc, it sucks so hard.
If you paste it, it will retain the HTML formatting and will begin. And it will become the code when you paste it. Until you decide to paste it without the HTML formatting.
If you just want monoface, choose like Roboto or Curried or something.
Yeah, I just would just monofaced it, and like, okay, but I've seen people do something magical and suddenly it looked very much like a color coded, like Google Docs. The whole ton of geeks. Why the hell isn't there a button that says, you know, it's coding style, and furthermore, fucking colorize it. Pick a default colorizer and go to town. No, fine.
Okay, I'm
sure Google had something.
Like to believe. I'm done hacking that if you wanted to hack that section. Yeah, see, the second half I didn't bother to do. It's too painful. Okay, what did that do? It was like pre-format or something?
This looks like Sam.
Like what?
The text editor, Sam.
Oh.
Familiar with Sam.
Okay, a quick poll we can.
Which kind of sucks.
I have one question. What do you guys want from an IDE? Not particular one. What do you want that it doesn't do right now?
Vigorous religious arguments. That's what I want of an IDE.
Okay.
Make that happen.
Oh,
I have to say
Emacs. What are you talking about? It's an operating system. It's a windowing system. It's a parallel computing system. You know, it's a text editor.
No arguments. No arguments.
Tell me things that the compiler knows.
I'm sorry, I couldn't hear you over the.
Mostly, I want my IDE to tell me things that the compiler knows.
Yeah, that's a good one.
That could be as simple as, I'm going to syntax highlight this thing because I know this is a keyword in the language.
Yeah.
But I would like it to do things like, oh, you mouse over this thing, I happen to know that it is an immutable variable that just got passed to you.
Either integration from the compiler with IDE.
Three types.
I want
if the compiler knows at this spot, this is a dynamic call and can be one of three things. If it could tell me the three things that could be, I would find that useful.
Yeah.
Okay.
Having used IntelliJ for years, there's very little I can think of that an IDE could do that it doesn't currently do. Although that said, they continue to add pretty cool things.
The major flaw I have with IntelliJ, it has a billion things that it does, and yet the things that I want to do commonly are just one of the billions, but they're common, so you have to go find them and do them, and still, like, I don't know, it's too many. It's like I don't need all these other things, like the refactoring things. I never use, occasionally use the rename refactoring. All other refactorings require so much minor changes at each call site that I can't verify that what it's randomly going to do for refactoring will actually make forward progress in a meaningful way, or simply hide all my issues by a random change because you thought this is what the refactoring is going to do. So you can't trust them for any of them. I don't know what the hell they're actually going to produce as a result. without hand inspecting every site. Well, if I fucking change the definition and I recompile, I'm going to get errors, and I'm going to hand inspect every site just as fast by hitting the next button in Emacs and hand inspect the site and fix as I go. It saves me nothing to have all the fancy refactorings on the planet in there.
I've been bitten in IntelliJ too many times by renaming a method like execute. And it's like, let's replace all usages of the word execute in your project with this new word. Oops.
I had some fun
but
Java
also speaking of
backstories.
IntelliJ, I'm curious if anyone else has had this happen. My IntelliJ has slowed way down in the last 6 months, which is now making me not love it. It's like squiggly red all the time. And I'm like, yeah, if I wait 30 seconds, it's going to figure out that this code is accurate. And that's like the new operational mode, which just sucks. Like, trust my IDE anymore. It could be the massive code base, but it didn't used to be like that.
Yeah, my solution to that was,
I'm sorry, I've had it go slow on me before and then fix itself with another generation update some, 6 months, a year later. So I don't, you may not want to wait a year.
Yeah. It's the going on 6 months and staying on the, whatever the latest they put out, and it's still slow.
yeah, no, my solution to the slowness ones was I paid for the Ultimate Edition, and
Yeah, I'm on Ultimate.
yeah, community is awful. Like my biggest complaint about IntelliJ was because it took me years to move over from Eclipse, and Eclipse is really god awful. Which is a shame too, because Eclipse used to be, I'm not sure whether it used to be good or I was just sort of at Stockholm syndrome with it.
Yes, the good old days. They weren't actually all that good.
But I really liked the workspace layout of Eclipse. I actually loved that. How I can have multiple workspaces with different JDKs in one thing. I was able to see the dependencies in each one of those projects without having to switch workspaces. And that was extremely useful to me. And now in Ideaj, I have to go into it and set up a separate module, and all the dependencies are in the same thing. And I just
whoever's hacking the code monoface that test case there.
What I really want from an IDE is the configurability of Emacs without the eLisp.
Meaning, can you elaborate a little bit?
I would much rather have I just hate writing eLisp for Emacs personally.
But you've done it in the past.
Yes, I have, because I have a very particular setup, which is me turning it into Vim and then using everything else with Emacs.
Oh, interesting. Okay, fine.
Yeah, evil mode. Like I've just been the Vim keybinds have just been ingrained into my every soul.
Right.
Every IDE I have now has it.
Right.
So that's
Emacs,
the first thing I do. Yeah.
Right.
Just install those keybinds, do that, and then fine. Emacs makes a Java IDE now.
A lot of us didn't have that choice because on Windows there was no Emacs and VI for many years. And,
Yeah.
Emacs showed up on Windows at some point, because I've been using Emacs in Windows forever. It went through a couple revs. There were some earlier, less useful versions, but like 20 years or more I've been on Emacs in Windows.
Yeah, I'm talking like 30 years ago when I lived in Redmond. All my friends at Microsoft, none of them used the Microsoft IDEs. They all hated it. Even the ones building the IDEs wouldn't use their own tools.
Yeah.
So they all used something called Visual Slick Edit.
Oh yeah.
Which was a Slick Edit GUI port into Windows, which was the craziest thing you've ever seen.
No, Emacs is well. My humble opinion, Emacs is way the hell better than Slick Edit. But fine.
Okay.
Well, and I think Slick Edit was kind of like, what would a DOS programmer do if they were trying to write Emacs?
Gotcha.
So I've got another answer for you. I'd like to mirror a little bit more of what Aaron said is annotations, but of a different sort. The compiler knows probably that it's got some profile data, it's got some JIT data from, you know, whatever. I'd like to see my code. I'd like to see the bytecode, the several IRs, and then the resulting machine code. And it knows this instruction's hot. I should be able to see this is hot.
I was there a decade ago at Azul. I put a HTML port on the backside, or HTTP port on the backside of a JVM, and the browser would let me surf the JIT's internal state fairly directly, including ultimately I was getting out assembly code with the hardware performance counters annotated with the Java, command lines. All of it was available at Azul more than a decade ago.
It's not available to me.
Right, and then Azul like hid it behind a paywall and tortured the hell out of it and was like stupid. It's like, no, this would have been the #1 way to get widespread adoption of the Azul JVM, was just put it on a fucking get that data drug out. As soon as that HTTP, the IDEs could have pulled it out.
And I could write a service that just goes and hits all of my production servers once an hour and grabs the data as to what's hot.
Yeah, we were doing it.
Background job, turn it all in and pipe that back to the user so they can see this piece of code that you're working on right now has not actually executed in production in the last 28 days. Changing this piece of code is not going to solve your bug because it doesn't actually run in production.
That's a good one. I hadn't thought about that one.
To give you what would, and either you can use statistics with what would be inlineable and what would be not, in order to show you how the code would roughly look like and combine it with the.
Well, I'm saying I actually had the running code with hardware perf counters.
Yeah, that would be better. Yeah.
Including all the inlining, everything else. So we would do that to customers in production because it was a always on, thing, right? And they fucking went ballistic. They loved it. It was like, oh my God, give it to me now.
Well, these days people use
together.
the same thing.
Sorry, could do either one of you because Zoom.
Yeah, people use JFR for this purpose these days.
I've never played with JFR, so I should probably at some point.
Yeah, that's another.
It doesn't go that low level though, right? It's not hardware perf counter level now, is it?
It has support to provide like custom information, and we're actually porting this. What Cliff is describing, we take the information from this tool and provide it as JFR events.
So you're trying to upscale JFR for Azul blocks. Yeah, okay. The tool, by the way, was just, I don't know, I used it for many years. It was fucking amazing. Every time I pulled that out, people's eyeballs would pop. And then I got 2x's to 10x speed ups on all kinds of people's codes.
Your estimate of the cost of collecting those metrics?
Oh, nothing. The JVM collected them all the time.
We were talking at work. We were talking like, why isn't there a profiler? Because we're talking something exactly like that for why isn't that an OpenJDK? Because the JDK is the best profiler that exists for Java. So.
Exactly.
So it is an OpenJDK. JFR is now part of OpenJDK.
No, pull out all the stats and do the mappings from the JIT code to the Java with all the profile data you have in hand, and show that sort of directly. Here's my inlining decisions, and here's where I did or didn't inline. Plus, here's the hot path through the code and everything else. It was easy enough to read if you could read assembly at all. It was easy enough to read, especially because I had all the annotations back to the Java code and the Java field names and the types and everything else was like thrown in the assembly.
You can see the caches, like, oh yeah, this thing has, this thing's megamorphic.
Right.
That would be cool to know.
Polymorphic inline caches that were blown out. It would actually let you surf the Java heap too as a separate thing. Count all your threads, get the profile data the JVM had running on per thread basis and shit like that. There's a lot of that data is in there, collected in a sort of extremely low cost way. So it's always on. It's under 1% collection overheads, but it's incredibly useful stuff. Drag it out. OpenJDK ought to do this. Yes, absolutely.
Does anybody actually make this that's available? Like I'm not going to pay for some commercial license for something because I'm Joe Schmo programmer.
Ask Arthur. It's Azul. So now what's the rules for when you get a free version? I don't know.
I think you can. It's either happened or happening that you can get evaluation license and use it for free. But we use JFR as a way to represent this information. We use different way of profiling compared to OpenJDK internally. So our profile is supposed to be more accurate compared to what OpenJDK provides.
Okay,
so
cool.
Cliff, any can expose all this in AA?
Oh, absolutely.
Oh,
that was a hard learning experience. I'm not going to let that one slip away because it was owned by Azul instead of by me. So
this would be a good market share if you provide that stats.
Yeah, that'll be there.
Yep.
So there's an implementation hasn't happened because I'm getting the typing sorted out. Maybe the typing's winding down. And then the implementation happens. And I think hard on the heels of a first implementation will be open up a port and let you grab data with a, background communication path. Have it, I won't let you modify things because
it also allows you to do a REPL. The convenience of just having I imported the IDE library, and now when I hit this port on my running service, it hands me a full IDE where I can see the code and.
Yeah, I'm thinking, well, we could argue that one. I was going to not allow modifications through a back channel. If you wanted to open a REPL, you would just open a REPL by, doing whatever. Demanding that there's an always available REPL that can't be turned off or not conventionally controlled. There's a security issue.
No, it should definitely be something you can turn off. But
right.
if the person says
problem.
Import REPL over.
Okay, well, as soon as I say text coding changes, then I'm just writing a REPL, which I have an eval, so you'll get a REPL pretty easily. Right, it's fine. Now you put a loop on it and you put an HTTP server and you have a REPL on a server on your guy. And we could even declare that there is a well understood easy library for this. So everyone does it the same way. So the tools can all chime in, but you don't want to have it on by default. Whereas a port that lets you people grab on any running JVM to go grab internal state. And we can argue that one should not be on by default too, but it has to be convenient. Like there's an easy way to grab the metadata that's profiling, reflective data that's profiling without making any modifications or changes. Is an easy way to go get reflective data. So that's the mental model here. Now, is it exposed by default as a port that comes out the back that you can attach to it? Probably there's an initial cut that says it should be super easy, but I kind of want to let you programmatically do it because then you buy into it and you get all the security of having a programmatic approach as opposed to there's a command line flag. I said AA space myprogram.aa dash port or whatever. There's some port flag or something, and suddenly I have open port. So I have a security issue, and now deal with that. There's always a trade-off: security versus convenience there. So there's probably a version that says the most easy thing possible is I say dash open up this kind of a port. I bought into the security issues that come with saying dash give me this port. So the guy that launches the AA server. I'm sorry. Say again, Aaron.
I was going to say you just put it in the standard library. If the first line of my program is import the web server, import the stats module, pipe the stats module to the web server.
Right. Launch a background thread that runs the service for you.
If that whole stats server is in the standard library and I just has the beginning of my line say import the stats library over web, start.
Yeah. Somewhere there'll be an import sys.perfstats and that'll have the reflective calls to bring out whatever internal profiling is going on. And from there you can build up the web server. And that's the buy into it with a little bit of code as opposed to
I would just put all the perf stats in the sys module and code that has the passed in has it passed in. And if you want something to not have it, strip it out of sys before you call eval.
Don't expose eval to whatever. The eval I haven't thought through how to do it, but there's going to be some way to automatically its visibility is restricted as a security measure to figure that one out.
I wonder if it could be as clean as eval takes 2 arguments, sys and the code.
I don't know. Well,
there shouldn't be a reason to not be that easy.
Well, eval, right? I mean, eval could just
functions for filtering sys, but
eval takes a code, but has no namespaces injected otherwise. But then you don't get any of the primitives that you might expect. So you want to have some of them. So then there comes a set of things that you would inject into eval that are grouped in different ways. Like you have sys, but you want a restricted sys. Okay, no one gets this right the first cut. If you're actually grabbing sys, over time, sys grows. Eval keeps getting a more expanded sys. I don't know. Should eval be allowed to see the number of CPUs? Should eval be allowed standard in, standard out? Yeah, for security in general, no. For ease of use in the current right now, almost surely yes. You know, if I'm taking random, I'm doing Godbolt's, you know, compiler server. Well, every fucking thing has to be, you know, carefully IO constrained and checked and whatever, right? So he can't let you just say, hey, I'm on a log file, I'm going to write terabytes out until your disk is full. It's a denial of service attack or something stupid. Nah, I'm sure he's got that all carefully. Okay, fine. So same for fork bombing yourself and all that kind of shit. What do you give eval and how do you constrain it in a reasonable way, especially over time as you want to add features and services to things like sys?
Right. I would argue let the community maintain a couple of different standard environments.
And this is the.
And I just import the sys.basic or sys.basic with networking or whatever. And I just grab one of the standard systems and pass it in. And it's up to the community to have a handful of blessed here's the systems, and most people pick one of the bases and add 2 or 3 things that they need, and usually put the security vulnerabilities in the 2 or 3 things they had.
Yeah, okay, I have to sort on making that one the right way. Like adding an argument to eval is weird, and why is it sys? But then the options are none or billions. Why 1? And if it's 1, why sys? Okay, maybe 1 makes sense outside of the code, but then why is it sys?
So, well, Python has 2, locals and globals.
Interesting. Yeah, right. Now, locals I get, although I could argue my way to locals being default handed by handing you the current function calls locals. And if you want to call eval with more, you pass them into you always wrap eval in a function. All those get exposed to eval. You want to pass something in, you pass them in that way. So then you have a hidden list, basically, exposed list, you're naming the things. If I want to pass in a fixed sys, I'll pass it in that way.
Right. And if I pass in dot, then I'm giving you the whole world. Like.
Yeah, right. And if you shoot yourself in the foot, you do. And okay, fine. That's you know. And it has to be convenient to shoot yourself in the foot, because as a single developer on my own desktop, the first thing I want to do is open all the locks and remove all the doors so nothing gets in my way. Right. So yeah, dot, short name, something that says, and everything. Okay, fine. And now go to town from here. Yeah.
Right, because you're going to need that for, like, say, the import statement.
Yeah, right. Whatever the hell you're working on.
Like, your import function is basically going to be go find the code and eval the code, passing in yourself as the environment.
Right. The first thing eval does is says import everybody. Well, okay, so import has to be whacked right away. So, you know, you have to hand him an import, or he can't go. Maybe you don't want him to though. He imports math. Maybe math's okay. He wants to go import org.apache.commons and get his zero day attack because he grabbed Apache Commons, right? Okay, maybe you want to say no. Val can't go go to Maven and download Apache Commons. No, I'm not gonna do it. You have to some security here. Fine. All right. It's 11:50. I didn't do last week's video. So you guys do you care? Does anyone care if I put the reason it takes so long to put the videos up is because I put a summary. If I skip the summary, the video goes up right away. I replay the fucking video. It takes 2 hours for a 2-hour video, and it's really boring, and I don't like doing it.
Yeah. The summary.
So you should at least be listening at 2x.
There's not some machine learning thing that'll just do that for you.
I don't have one. I haven't seen one.
Intern.
That would be nice.
Be careful, because there's a email address in the middle.
Yeah, there is. Well, you know, Max Bernstein gave it on video. I expected him to hand it to me in private chat, and I got it on video. So I want to claim he bought into his trouble there.
Okay, we can do another one. During the talk, the document, we just put the timestamp when the theme shifts, and that would be easier.
It would, actually, if I could just skip. And I'm okay spending 10 or 15 minutes, but it takes me an hour and a half, and then it's like, yes, I skip fast, but you can't skip everything, or you don't know.
It's 10 seconds to add a new line, and we can do it all. So let's try it next time.
Yeah, that'd help.
Okay.
That's a good answer.
Yeah, if we turn the doc into a log.
Yeah. Timestamp in the log, it's all good. Actually, there's no timestamps in this guy. It's fine. Okay, fine. Cursor parking lot. I love the cursor parking lot. All right, I understand what it's for now. Yeah, I have people like go explore it. No, I'm not going to use it on a regular basis. It's too much trouble, but it's a cute idea. All right, I'm done. Till we meet again. Maybe next time I'll get the email out.
Okay, cool.
All right, it was good conversation, and hope to see you next week. As soon as I find the end button.